based here. So he's a technical expert as part of the, sorry.
Yeah, I'll mute, Andre, I'll mute the people.
It's probably Walter. And so we've got an opportunity to hear from directly from Wernfried on the features and the updates and the changes that might be occurring. Many of you are already Tarana installers. You've got experience of dealing with the technology in the field, and I know there's probably going to be some questions around firmware upgrades and those sort of things. This is your chance just to get a full understanding of that. I'm not going to belabor it. Maybe Wernfried, you can also just introduce yourself as well. You've got, as Sharon said, quite a range of technicians. I'm sure some will join a bit later. But from your experience, the Techie fleet, and you can help us do better in terms of making sure the customer journey, the experience of the ISP and the experience of the end client using your technology. We've had some good reports, and then we've had some issues. As you know, we've got clients that are having problems, but the problems tend to be outside of the Tarana radio network, and could be things like base station vandalism, backhaul links, and that sort of thing. But you know that all of that sort of factors in. The client doesn't understand all of that. So that's it from my side, guys. Thank you for the Wernfried, thank you personally for your time here, and I'll hand it over to you.
Okay. It's Eric sharing his camera. Okay, no problem. Okay, good evening, everyone. My name is Wernfried Hesse. I'm the solutions executive for Tarana Wireless, which is a global company based out of, so our headquarters are in California, and I'm responsible for the EMEA region, and I also assist our teams in the Asia Pacific area as well as in South America. Sometimes I get quite busy with planning and doing technical presentations as well as training. Okay, so I'm going to jump straight into it. So MTN is the owner of the Tarana network in South Africa, the largest operator network currently deployed by Tarana, well, with using Tarana technology, where MTN has deployed over 629 base stations all over the country, providing connectivity. Now, one thing that I want to make clear from MTN, their design is a 5-kilometer radius from the base station. So they designed the entire Tarana network around a 5-kilometer radius around each and every site. However, having said that, there are links that are able to connect beyond that range. Now, just be aware that when you do feasibility planning on links, or when a customer has requested a link to be installed, that link would have been designed within 5 kilometers. Needless to say, it does not mean that the link you are going to install will connect at 5 kilometers, because you might find a better base station that is 7 kilometers away. So those things you have to keep in mind. Okay. Tarana, as configured on MTN today, sector range has a maximum distance of 15 kilometers. So we can connect links up to 15 kilometers away from a base station. Okay. So those are some of the key things. The next key thing is we are in talks with MTN to start rolling out a new firmware upgrade. So MTN is already 3 revisions behind our current latest release. It is under test by Sean, who's the responsible person for firmware checks within MTN, which means we are going to get to upgrade their network, which has massive improvements. But I'll get to those things later on. One of the things I want to address quickly is just to make everyone aware. I'm going to share my screen. So we at Tarana, we do have a training portal available with a lot of information that you can access for free. You just have to sign up and you'll be able to access this information. There's a free training course that you can do to test your own knowledge. You can run it as many times as you want, but there's a resource library where you can download the latest documents, spec sheets, installation guides for both the BN and RN. I know you guys only focus typically on the RN, but that is available. Can everyone see the screen?
We can. Thank you.
Okay, so that's a website. You can memorize it. It's just learn.taranawireless.com. You can sign up for free, and then you can start accessing this information. Okay. Another thing that I want to just show you quickly is, let's go to the next. I've got the wrong screen open now. I just want to show you what the screen looks like. So this will be the landing page, and you can sign up. So the dashboard, the catalog, and resources. This is where you'll find all this relevant information. Just to quickly show you what everything looks like, so that you feel familiar with these things. There's the resource section where you'll find documents. Whenever in doubt, you need information, this is where you'll start to look for it. Now, new things in Tarana. Before we move on, are there any questions on the training portal?
So, guys, we will make note of that that website, and we will put it out on the active installers group. Thank you.
Okay, great. So moving on, Tarana has focused a lot of its energy on the new 6 gigahertz radio. Now, there's been a lot of firmware changes, a lot of changes on the actual hardware, but I wanted to make you aware that the 6 gigahertz product might hit South Africa. We are just waiting on ICASA to give the go-ahead to allow for the lower 6 gig band to operate our solutions. Now, the key thing is when I talk about 6 gigahertz, there's a lot of bandwidth to play with. So currently in South Africa, with MTN, we're only allowed to operate in the UNII3 band, which is the 5.8 gig frequencies. The entire network is configured on these 2 frequencies, and that's where the limit is. We don't have more space for more spectrum. So previously, you might have heard something called X2 mode. That no longer is applicable on the G1 5 gigahertz system. The X2 mode will only be available on the 6 gigahertz product. And what X2 will mean is you can now deliver a gigabit link to a customer, roughly about 1.2 gigs in the downlink and up to 500 megs in the uplink. Now, this uses 4 40 megahertz carriers, and that will be the new stuff that might hit South Africa. So we are completely ready for this. It's being deployed in America. It makes use of a database. So you'll see the point that says AFC database. That's a database that South Africa will also duplicate, which will allow the RN and BN to select a frequency that's available for that specific link to operate in. Now, the advantages of this is the 6 gigahertz spectrum is not as polluted as the 5 gigahertz, making high-speed, reliable links very much possible. Okay. Some of the other things that we've integrated are new 5 gigahertz RN. Now, unfortunately, MTN has a lot of stock currently on the previous RN, but the new RN is 802.3 BT compliant. Now, that might be a high technical term, but what it means is we can now power our RN directly from a PoE-enabled switch. So with the new RNs, the new 5 gig RNs, as well as 6 gig RNs, they can run directly from a PoE switch. Another addition that we've added on the 6 gigahertz is on this graphic. We've now added, let's call it a signal strength LED strip to aid our installers to know which alignment is better or not. Okay. Just some of the overlaps in band. Now, the nice thing about the 6 gigahertz, it runs from 5.8 all the way up to 6.8. So if MTN decides to roll out a 6 gigahertz base station, all the current RNs on the network are still compatible with the 6 gig DN, as long as the frequencies match. So in 5.8, which MTN uses, all the RNs, new and old, will still be able to connect to these DNs. Okay. I don't want to dwell too much on these things. Are there any questions?
Sounds like a very exciting rollout happening.
Yeah, we're waiting on MTN to start pushing these things. Okay, let's get to the RN installation. I just want to touch a few things very, very high level. There's been changes from MTN with regards to the operator ID. So on remote load, your checklist, these are the typical things that I still advise you gather before going to site. Your operator ID. Now, please note, I'm going to say it a couple times. The MTN operator ID is no longer 0. If you use 0, it will not connect to the MTN network. Okay. The operator ID.
Thank you. I hope everyone's listening to this because we had those issues today.
Yeah. So the operator ID for MTN is 14. Number 14. So just to stress it again, operator ID 0, the default, will no longer work on MTN's network. And there's a reason for this. The reason was that other installers from other operators were jumping onto MTN's network, and they did not like that. So MTN asked us to migrate the entire network to their own operator ID, and we had dual operator mode for a couple of weeks to get everyone onboarded on this. But from this week, Monday, we switched off the operator ID 0. It will only operate on operator ID 14. I hope everyone is clear on that. You have to use operator ID 14 in order to connect to MTN's network. Okay.
And just a question, Wernfried, if we have another operator coming on board, they'll give us their ID, right?
That's correct. So every new operator, we at Tarana assign an operator to. So it's not chosen by random, we assign it.
Okay, but this, maybe I'm confusing the thing. If it's an ISP on the MTN network, it'll still be 14.
Correct. Yes. If you use MTN as the backhaul or retailer network, it will be 14. Yes.
Okay, understood. Thank you.
Okay, next up is the preferred BN. So when you do the installation, it's advisable that you write down the BN serial number if you have that. Okay. You don't have to worry about data VLANs. MTN has decided not to change any VLAN in their network. It will be the standard VLAN. You do not have to change the VLAN in the RN at all. Another key thing that I want you to also memorize, everyone should know this, is the default GUI login IP address. So we prefer at Tarana to use Chrome, Google Chrome. And if you get an RN with a very old firmware version, like 898 or 816, this connection standard in Chrome will not work. It will fail, which means you have to change it to HTTP and then that IP address to connect to the RN. Do your firmware upgrade up to 997, which is the current standard, and then you use HTTPS, which is the default in Chrome. Okay, are there any questions on that?
No, we're good. As I see hands been raised, I'll interject and ask you to pause to take the question.
Okay, perfect. Thank you.
Guys, are you all understanding this? Please ask your questions, because once this is done, I'm going to expect you all to be doing it correctly.
So there's another demand from MTN, and they made it very clear that I must mention it to everyone. Okay, I see Techie has his hand up. Go ahead.
Selwyn?
Oh, yes. Just to inquire about the connections that you've just mentioned across ISPs. Is it safe to have the radio node connect without, any encryption to the base node? As I've seen that they are open node connections.
Okay, it's a very good question. So each one of our devices is encrypted with an AES 128-bit encryption using a Tarana signed certificate. Now, this is the reason why we need to do firmware upgrades. And I'll get to the firmware upgrade in a second. So just listen for that. I'm going to explain the security of how to connect to MTN. But still, you need operator ID 14. That is your first step into the network. Then we need the firmware upgrades to be done in order to establish a reliable, secure connection. Okay. So just listen for that. I'll address that in a few seconds. So MTN has stressed that I must mention this going forward. If we discover a remote node on the network that is not upgraded, MTN will demand, and this is their words, MTN will demand that you go back to site at your cost to do the upgrade. This is an instruction I received from MTN to mention to everyone. I'll repeat. If MTN finds an RN connected onto their network that is not on the minimum firmware level or upgraded, the installer will not get paid. They will have to go back to site to do the firmware upgrade up to the minimum supported level in order for this network to going forward. I hope that is clear. This is the only instruction that I need to relay.
That's obviously from the time of installation going from now. So you can't implement a rule like that going back to 5-10 months ago.
Correct.
Yeah, we
Going
Doug,
forward.
just for your info, we're busy moving over from Supersonic to MTN, where MTN will send us the orders in order to go and install. What we'll then do is our installers will only be installing the RN and making sure that with the test router that it's up and working. And the ISP, be it Supersonic, whoever that MTN has asked MTN for the installation, will then dispatch the router, which is apparently like a plug and play. So at the moment, we're still doing the full install from RN to router drop, everything, but that is going to change in the future.
Okay, but just to clarify something, Wernfried, with regard to what you've just said, is Supersonic have very seldom, if ever, tell us what firmware upgrade needs to be done. So the communication between MTN, the ISP, and us, because currently we're working to Supersonic, in the future we'll work to MTN. No one's telling us what firmware upgrade, and we're flying blind still, but hopefully that will get resolved once the MTN relationship is properly bedded down.
You're absolutely correct, Andre. And I was under the impression, and I've had various meetings with MTN stakeholders, and they told us categorically that they've informed every installer, including Supersonic, that they want the firmware to be upgraded. So going forward, like you rightly said, if the relationship is now moving over to MTN, that we are aware of, Supersonic will no longer install or instruct RN installations. It will all happen directly from MTN. And their instruction is that firmware has to be done to a minimum supported level. So I think it's Lee has a question. Hands up.
Yes, it's me. Yeah, good evening, everybody. So if you say minimum supported level, right? It's a little bit of a vague term because we get BNs that's on multiple different firmware versions. We've got some that's on 997.31 now. We have some that's still on 997.28.
That's correct.
And so if you say minimum supported level, is it anything within the 997 range?
Yes. So the minimum supported current valid firmware level is 997.028 is the lowest version that you can install on an RN. You don't have to worry about the BN. The .31 was just attached to fix a DNS issue, but it has zero impact on the RN. When we at Tarana roll out any firmware, whether it's BN or RN, and it only affects one, we'll upgrade and release two files, one for the RN, one for the BN. However, the RN file, there were no changes. So the 028 is still the minimum supported firmware that we need now.
So does that mean 028 and 031 on the RN is essentially exactly the same thing?
Absolutely correct. 031, 028 on an RN is exactly the same firmware.
So 016 is not to be used?
No way. 916 is deprecated. We at Tarana no longer support it. And also, when you try to connect an RN using that firmware level, you will struggle to get the connection because the
not 916, but it's 997.016.
Yeah, it needs to be 028.
Okay.
So 997, not 977. 997.028 is the minimum firmware level.
Okay. Noted. Yeah.
Syed, you've got a question?
Oh no, they can carry on. I think it was answered already. Because I
Okay,
wanted to ask something and then Lee also brought it up within his question as well.
Okay, so you've got your answers. Fabulous. Thank you.
So also what we'll do is all firmware going forward, every time there's a new official release for MTN, I will share it with my techie. I'll make it available. We at Tarana are not shy to allow our firmware to be available for everyone to download. And this is 997028 will be available. I will even give the 3.1 version available. It's really not a problem. If you guys struggle with that, reach out to us. We'll get the firmware to you. Okay. So
Awesome, thank you.
the reason why we hamper on firmware. So I've mentioned in the beginning that MTN's network is already 4 revisions below our latest release. And with that is deprecation. So Tarana has deprecated firmware that's below 997.028. What this means is the certificates are no longer valid. So if you have an RN with a 916 or 977 firmware on it, and it tries to connect to the network, it will establish a connection, but it will not function. So this is where the troubleshooting comes in, and some links are struggling to get connection and the stuff doesn't work because of the firmware. Okay. Now, like I also said, MTN is in the process of testing the latest firmware, which is release 2.0. Now, 2.0, we are earmarking to roll out on the MTN network within the next month or so. So, having said that, all RNs that are not on 997.028 will not be able to upgrade to release 2.0. So this is where the problem comes in. Any RN that's on the network that doesn't meet the minimum firmware level cannot upgrade to release 2.0. So this is the migration and upgrade path that we need to focus on. Any RN that MTN gives you will most likely have old firmware because they bought in bulk. They've got a lot of RNs in stock. Those RNs will most likely have an old firmware on it. My recommendation is to do the firmware upgrade to 997 first, and then upgrade to release 2.0. Now, why we need to do 2.0 is because there's a massive advantage in the path loss as well as in speed. Okay, there's a couple of features that I'll show now that will show up on the RN GUI that might confuse some people. That's why I'm showing it. But going forward, if you install release 2.0, there's a couple of new things that will be shown in the UI that might be of use. Okay. So the IP address will still be the same, 192.168.10.2. It will be HTTPS. And we will now show what the new RN GUI will look like. This is still release 1.2, but this will change to 2.0. Okay. We'll have a dashboard interface, setup, diagnostics, and the reboot menu. But you'll notice that the color is no longer green, it is blue. And under setup, you'll now see these the following boxes. Operator ID, that is where you put in operator 14. Primary BN, if you know the planning ID of the sector that you need to connect to, this is where it would go in. My recommendation is leave it blank. You'll then see something called a priority search list. Priority search list is where you can configure the frequencies that you want to scan first. This allows the RN to connect faster to a BN. Typically from 5 minutes in normal, it can now connect in 2 minutes if you configure the priority list. It's not needed, it's optional. I'm just showing what the new GUI would look like.
Any questions, guys? Okay, so you're all good with this,
Hello.
right?
Yes, I just need to. This is basically for the G6 or still the G1 RNs.
That's the 5 gigahertz G1 RNs, correct. Okay.
All right, noted.
Awesome. The radio states, so you might have seen all of them. The first one is searching. Now, what will happen under the searching phase, if there are multiple beings in the area, you'll start seeing all the planning IDs populating in that table below and showing the frequencies, search metric, and all of those things. Okay. MTN has already updated all of their planning IDs on the entire network, making the confusion in the previous installations null and void. So from going forward, all the planning IDs will now be unique for each and every sector that you connect. Okay. So the radio will go into search mode. It will scan the frequencies. It will find all the beings that it has access to, and it will list them in this table. Directly after that, it will go to initialization. So initialize means it's going to connect to the being that it's selected. That step is typically very fast. Initialize means it's just talking to the being, and the being is saying, yes, I'm allowing this connection to happen. And this is where the certificate comes into play. If the certificate is invalid, this might interrupt the link and the RN would go back to searching. So it'll go initialize, searching, initialize, searching. That's because the certificate is expired. After the third setup, which is now calibration, this is where the RN needs to be completely still. It will calibrate the link and then connect to that being. Once the connection is done, you are all familiar with this, but I wanted to show you a few things here. We now pull in the BN serial number, the planning ID of that BN, as well as the host name. This will only be visible once the connection is established. Okay. From there, you can put in the host name if you need to, but one key important thing is try to input the coordinates. It makes it very difficult for Tarana support teams, which are not located in South Africa, to do any kind of support on an RN if they don't know the location. But if you have the location, please put it in. It's in decimal format. Okay. Okay. Let's go to the next slide quickly before I show interesting stuff. Okay. Another problem that I've noticed that happens on some installations is the cable length that an RN can do. I've not seen it in any of the MTN supersonic installations, but however, I have seen it on MFN links, where the cable distance from an RN to the PoE, from the PoE to your switch or router, exceeds 85 meters. If the cable that you're using from the RN towards the PoE is a category 5E cable, the total length cannot exceed 85 meters. If you're using Cat6 cable, the total length for this cable through to the router can just be below 100 meters. Okay. So there's some of the things that I've noticed. Then we'll get to diagnostics. So there are a couple of diagnostics that you can now do from an RN with the new firmware. If you go to diagnostics, you'll start seeing this page. The GPS lock will only be applicable if you've got a 6 gigahertz RN, so that won't be shown. But a key thing that I need you to check every time you install a link is the RN certificate valid? Okay. The next thing that we are now also adding onto the RN is the air interface protocol. And this is because we are preparing for our next generation BN, which will be the G2 coming next year. Okay. The G2 is a different kind of beast. MTN has already shown interest on it, and it might be entering the MTN network. However, it's going to run on a different air interface protocol. So you'll start seeing all the RNs showing that. Yeah. Under the diagnostic screen as well, there will be a new feature for speed tests. The speed test is much more reliable now on the new firmware, where you can now pull a proper speed test as if you're doing a speed test from the BN towards an RN. Okay. The speed test will run downlink first. It will pull the latency. It will do an uplink speed test, and it'll show you the frequencies and the RF range and those things. Okay. Another thing that we have is under diagnostics. So under diagnostics in an RN, you can do a DNS lookup. Now, very simple, because you're on MTN's network, you can simply just type in there www.mtn.co.za. If you get a positive response, that already shows that the RN is properly configured on the MTN network. And the likelihood of you having a successful installation with no hiccups on the backhaul is very, very low. Yeah. Okay. I think that is mostly what I wanted to show for this. Is there anyone that is familiar with the Tarana technology and how it actually works?
Who is familiar?
Yeah. Has anyone ever heard of what the Tarana technology actually does and how it works?
So it's the Tarana installers online at this particular meeting, but please, we may have it a little bit wrong. Oh,
I think Wernfried is referring to their unique value proposition in terms of their antenna and the beamforming and the ability to pick up all the different channels. So, yeah, we do other installations with competitive equipment like Cambium and others, which are much less, they're not as forgiving as this one. So I think that's what you're referring to, Wernfried.
That's absolutely correct.
Yeah.
So what we call it at Tarana is currently everyone is talking about fixed wireless access. Tarana is now considered a next generation fixed wireless access. And how we do that is by these things. So I'm briefly going to talk about it. So we've got our own CPU, which is that chip on the top right. So we're not reliant on any other people's technology. We have our own chips. We make and manufacture our own chips. We've got the SoC, we've got an analog.
Where do you manufacture them? Where do you manufacture this? In Taiwan by any chance?
Yes, they were made by Taiwan Semiconductor, and we've got stock.
Okay. So we had a massive semiconductor shortage a couple of years ago, if you remember.
Yep. Yes.
So when China decides to invade Taiwan, we'll have to have some stock here, please.
No. We have zero problems with stock, as this is our own chips. Okay. So even the radio chips, companies had issues with the RF chips from 802.3bt and 802.11. Those chips, we are not using any of them. We are using our own technology. So that's the third chip, which is the RFIC chip, which is our radio chip. So everything is custom made, built from the ground up. We're not taking 3GPP standard into account, 802.11 standard into account. This is a Tarana standard using the unlicensed band. So we've got a multi-teraflop processor on the RM, which is a 2.7 teraflop processor. That's more or less equivalent to an Intel i9 laptop. It does a lot of digital math computations, and that's why we have it. The next key thing is we've got something called massive distributed MIMO. Now, what this basically is in a nutshell is we've got MIMO antennas on both sides of the link, which gives us a unique advantage in beamforming as well as in interference mitigation and cancellation. Okay. Our next big thing is called ABIC. So ABIC stands for asynchronous burst interference cancellation. What this does, it detects interference sources and place nulls in those directions, and in effect cancel the interference. So to compare it to technology that most people would know is, these headsets that you can buy that has this noise cancellation feature in it, where you can listen to music without hearing the outside ambient noises. More or less the same in Tarana. We can pick up other people's interference, place nulls in those areas, we change and cancel them out that they do not affect our link. And this has significant advantage. So in combination with beamforming, our distributed MIMO antenna system, as well as ABIC, this is the reason why Tarana can do these kinds of links. Okay.
Guys, remember there's a test at the end of this. You better be concentrating.
So, because of all of this stuff, we can use the same frequency on all the sites and on multiple sectors. Yeah. So you might have noticed now that when you try to install an RN, you see the same pair of frequencies every time. And that is because the entire MTN network is running on the same set of frequencies. You might see that there's other sectors that are using different frequencies, and that's because our support teams have gone in and optimized some areas where we are seeing problems. Okay. But the majority, almost 90% of all the BNs currently configured are running on the same set of frequencies. So we can claim a frequency reuse of 1. No one else can claim that. Okay, the next thing is we can do reliable links at close to the sector edges of 15 kilometers. I've recently done a test in Ethiopia where I've installed a link at 14 kilometers, delivering 400 megs in the down and over 111 megs in the up. And if you guys are, and if there's time, I can demonstrate this link live. Okay. Features that we also do is perfect multi-path integration. What I mean by that is the RN has a 55-degree wide antenna, which allows it to get all the energy from multiple sources, be it reflected, refracted, obscured, whatever means are there. We want all the energy. And because of the massive power in the CPU, we are able to reconstitute all of those signals into a usable frame. This is where the reliability comes into place. Okay.
So guys, when you say no line of sight or something like that to fail and install, it's going to start being questioned. Please make sure that when you failing any installation, you've taken all of this into consideration.
Correct. And I'll talk about the link classes in a minute that everyone is familiar with. But next up, I want to show you just an overview of all the equipment that Tarana currently has. So we've got our 3 gig system. The 3 gig system is in the States, however, it's a licensed band. It runs from 3.3 all the way to 3.7, where CBRS runs from 3.5. Very reliable speeds. This frequency band is typically used by 5G, and we can coexist with 5G. So if MTN decides to use this frequency band, we can coexist with their LTE base stations running the same frequencies. Okay. Next up is the 5 gig system that we're all familiar with. Some key things, we can connect upwards of 250 remote nodes on a single sector. Currently in MTN's network, the largest sector is in Cape Town, and it's currently running at 119 customers on that single sector, where the majority of these customers are 100 meg customers. Okay. In our 6 gigahertz product now, one thing I want you to see is the overlap in frequency. You see there from 5.7, it matches in the 6 gig. So if we've got a 6 gigahertz BN installed and you want to have a 5 gig RN, it will be able to connect to that 6 gig as long as the frequencies match. Okay. However, in the 6 gig, we can now deliver over gig capacities to customers. Be it closer range, but we've done tests where we can deliver a gigabit speed at 3 to 4 kilometers from the base node. Okay. Go to the next slide, quick. This is the RN and the high level specs. So these are the network profiles. If you understand network profiles, so MTN is running an asymmetrical network profile, which is the default 4.5 to 1. That's why you see a high downlink and a smaller uplink. So basically, in a nutshell, 82% of the aggregate capacity is allocated into the downlink, and the rest is allocated into the uplink. Okay. Tarana can do line of sight links at a maximum distance of 30 kilometers. This would typically be in rural deployments where height is our friend, so the higher towers can connect line of sight links up to 30 kilometers and connect 100 meg services. Okay. Near line of sight, that's a small n, near line of sight, just below 5 kilometers. Okay. And then non-line of sight links up to 1.8 kilometers from the base node. Okay. I want to jump into the link classes quick to explain what they are. So everyone knows what line of sight is, which means your signal beam, and we know that 5 gig is a very wide spectrum, so the beam looks very, very wide. So anything that's in the 3rd and 5th Fresnel zones is considered impact in the main beam. So line of sight, we want a clear path towards the other end of the link. That's considered line of sight. Near line of sight with a little n is where we've got partial obstruction in our Fresnel zones. Typical installation would be if you install the RN and there's a tree in your field of view. So imagine the following. If you're looking in the middle down on an RN, straight down towards your sector, take about 15 degrees to the left, 15 degrees to the right. If you visibly see it with your eyes, that will be an obstruction to the RN. Okay. Non-line of sight, we've got complete obstruction for that link. And this is where we make use of multipath in order to establish these kinds of links. We can take advantage of reflections. We can take advantage of diffractions. And all of these different things play a role on how we gather this signal. Now, we can change our beams 5,000 times every second. And this is the reason why we can achieve these high reliable links. Okay. Any questions thus far on this?
No hands are raised.
Teams, you need to ask your questions now because we get a lot of failed installs. So surely this explains a lot of what you see out there. So please ask the questions so that we can get the answers.
Wernfried, will the avocado pears on those trees be cooked?
No. So 5 gigahertz frequencies, fortunately, cannot have zero impact on matter.
Okay, so we're going to see less failed installs now, right?
Yes, you should see less failed installs.
Now I'm talking to the teams after you're showing them here.
Yeah.
Thanks.
So another slide that I also want to show, and this is something that where Tarana plays a big role and where our beamformer comes into play. In existing solutions where we've got, imagine on this side, you've got an RN there and an RN there, and it's speaking to 2 different sectors, it becomes a challenge for the RN to know which one is talking and which one is not. So if you're in a room and there's 2 people from different angles saying different things to you, it's hard to understand what they are saying. So you need to isolate one in order to understand what that person is saying versus the other person. And this is what Tarana does in a nutshell. We can precisely send our energy where we need to. And this is why when you install an RN, you just point it towards the BN. It self-aligns and it creates an optimal path with something like a phase lock loop, recalculates this link 5,000 times every second to optimize and maintain that link. And this is one of the key unique features of Tarana. Okay. Okay. Then I want to show some sample links quickly. So this was our very first installation in San Jose in California, where I'm focusing on the 3-kilometer range from the sector. So the sector's on the top there. I'm just focusing on the 3 kilometers. So what I want to show you are these 3 links with lines to them. The first one is a near line of sight example. The middle one is a non-line of sight example. And the last one is a high distance link. Now I want to stress that all of these links are able to connect to the same sector with over 400, well, I would say almost 90% of these links are over 400 megs in the down. Okay. Now, these are Google Earth images from the location of the RN towards the BN. So on the left-hand side, this is a 1.5 kilometer non-line of sight. The RN is installed on this building over here, it needs to transmit through these trees, through that building in order to reach the base node on the other side. Okay. Here's a near line of sight condition. So the BN is on the side of that building over there, where my laser is showing. And because we've got partial obstruction in the main beam, we've got a near line of sight condition. This is 2.5 kilometers from the base node. And the last one is an 11.5 line of sight link, where the RN was installed at about 5 meters above the ground. The 5 meters above the ground, on that house, it was able to connect. All three of these links are over 440 megs in the down. Okay. Okay.
Any questions, anyone?
I just want to ask, when you refer to the down, you're referring from the BN to the customer CPE?
That's correct. So downlink is always referred to the signal that you receive, your bandwidth that you receive. So bandwidth from the BN towards the RN, yes.
100%. Okay, cool.
Yeah. So we've also got the new release notes out for the new firmware that MTN is going to run to. And I want to give some high-level advantages that's currently in the firmware that has made our links even more impressive. Okay. So one of the key features that has been done since 997 up to release 2.0 is there is an ability in the RN to reset the configuration. So what this means, if you have an RN and you're struggling to connect or the configuration is a mess, you can go to troubleshooting. There's a setting that says reset configuration. It will reset, clear out the configuration that's in this RN and reset it to a factory configuration. So that's a new feature that's available in the new firmware. Okay. Next up is the overall latency of our links have been massively improved. So speeds from customers with regards to latency have been improved. Speed tests no longer show that they fail, and also show now the correct values in the latency as well as the downlink and uplink. Comparably close to 98% as if you're running an actual speed test using iPerf. Yeah. The certifications or the certs no longer show invalid even though they are valid. So that has also been addressed and fixed. Something that has happened in some of the links is where we have SLAs applied. So you might have heard that some of the links is a 5 meg link or a 50 meg link or a 100 meg link.
Sorry, and there's a question
Yeah,
that Footy wanted to ask, and he wanted to ask if the maximum radius range is increasing with the new technology, and does this allow them to go beyond the initial range currently available?
Okay, so as I mentioned before in the very beginning, MTN has designed their network around a 5 kilometer radius.
Okay.
Okay, so that's MTN's design. However, if you're on site and you establish a link at 7 kilometers and it's a high capacity link and meets the customer demand, why not install it? Why fail that install? So that is something that we at Tarana are addressing with MTN to say, do not fail these installations. Your recommendation is stay within the 5 kilometer radius of the BN. However, if there's a better link to be made beyond that radius, do not fail the link. So that is something
I
that
think
we work on about
I think we're working on about an 8 kilometer radius at the moment.
Yeah, no, that's fine. But what I mean is MTN has defined and created their network at a 5 kilometer radius. And in some cases with previous installers, they failed installs that's beyond that range. Okay.
Is there any danger, Wernfried, if you do put it in and it's a 7 or 8 kilometer link and it's like middle of winter and then summer or spring comes along, or I don't know. So are we going to be able to maintain the quality of that link over time?
Absolutely, absolutely. So temperature does have an effect on the frequency base, but because of the technology and how it works, and we're changing this beam so often, we compensate for all of these atmospheric changes.
Can you compensate? Can you compensate for MTN backhaul flapping?
Unfortunately, not. So that's the backhaul network here. I can only talk about it, Tarana, unfortunately. Okay. Another key thing that we've now addressed. If you have firmware release 2 installed on your RN, you'll now see a 3 dB path loss improvement overall on most of your installed links. Now, to put this into perspective, I've got a customer in Cape Town that that wanted to install one of his clients outside of the sector. So it was about 30 degrees outside of the sector. It's about 2.8 kilometers from the sector. He wanted to sell a 200 meg service, but the link in the previous firmware could not get 111 megs. We upgraded his network to release 2.0, and the speeds jumped up to 400 meg in the downlink. So you can now comfortably sell the 200 meg service to this customer, which is 30 degrees outside of the sector view. So that's just one of the examples. I've got countless more to indicate the improvements that this new firmware has done. So what this means for an installer, if you're running firmware release 2.0, the chances of you getting reliable links have now increased dramatically. The overall path loss has been reduced by 3 dBs. This is all in math. The latency is improved, and we've managed to get about 60 meg improvement in the downlinks in almost 80% of all the links. I saw someone had a question.
They're asking what is the lowest signal we may install on a link based on the new firmware?
Okay. So I guess he's referring to the alignment metric. So there is some confusion on the alignment metric. The alignment metric is not an indicator of receive level or speed. The alignment metric is basically a control channel, one resource block that we allocate from the BN towards the RN to just optimize and create our optimal beam path. So the minimum alignment metric that I would recommend is 12 or better. And personally, if it's lower than 14, I would not install the link.
So guys, 14 and above. So it's as we've always said.
Yeah, 14 or better, you will probably get a high quality link. Obviously, the higher that number in the high 20s, that's where you get your best speeds. But
And then also customers will be able to upgrade their service if need be.
Yes. So having said all of this, the best indicator for link quality is your path loss. So our best modulation runs at a path loss of about 124, where the lowest path loss that we considered in South Africa, if it goes beyond this, I would also not install the link, is 138 dBs. So if your path loss is is higher than 138 dBs, I would also not install the link. It's a waste of time.
Clemens, you've got a question?
I just wanted to add. Oh, network. Hello, sorry.
We can hear you, Clemens.
Yes, no, I just wanted to add on the signal strength to say a tram signal strength alone is not, the matrix is not the best indicator. The only thing I value also is the path loss must not be greater than 30%. That's what I wanted to add. But
thanks, Clemens.
So it's absolutely correct. Path loss is your best indicator for your link quality. The next metric that I would start looking at is the SINR value, which will now also start showing in the speed test. So if you do a speed test from within a Tarana upgraded RN, and I can show you a picture of what it would look like, that speed test would also show the SINR values. Let me find a photo quick. Are there any additional questions while I search for this picture?
Any other questions about the path loss and the speed tests, guys?
Yes, Chair. I just needed to check something because at sometimes you would get a path loss of maybe 139 or 140, but when you check your speed, it's very just a little above what the client is seeking. Actually, let's say if a client is seeking for 100 meg, maybe you would get 180. So is it recommendable that we install the site?
Sorry, just repeat the last bit. I lost you there for a second.
No, I was saying sometimes the path loss, it might be just above 138, like you just said. It's recommended that you install below 138. So sometimes we would get this when we run the speed test, we would get something just a little bit over what the client is actually purchasing. So is it?
Yeah. So you will be able to install the link, it will work. However, now you've got no fade margin to work with. So for example, if it starts raining or there's any other interference source that degrades your path loss, which we all know happens, then this customer service will be impacted. So for example, let's say he ordered a 5 meg service and there's a massive interference surge from someone else in the area and his path loss now jumps to 141. His link speed will not exceed 2 megs. So now you no longer have a margin to play with. That's why I say our minimum path loss, I recommend personally, to not go beyond 138. Yeah. But you're absolutely correct. If the client, if you inform the client to say, listen, it's on the edge of what the path loss recommendation is, you still want us to continue this link installation and they agree, just note it down on your installation notes that this customer agreed to this installation and make them aware that if there is rain or any fade in this link, there is no room to play, if that makes sense. Okay. So I want
That
to show
answer
you
your question, Kamagela?
Yes,
Yeah,
it does.
good.
It does.
Okay. Clemens?
Okay, no, some of my network was breaking. I did not hear about the limit as 138, but mostly I thought according to the spec it was 143.
So you're absolutely correct. I don't want to confuse people. Our Tarana specification in America is 143 DD. However, in South Africa, where we have tested and done a number of checks, our findings was that in South Africa, the recommended lowest path loss is 138. So Clemens, you're absolutely correct. That's the Tarana spec for America. However, in South Africa, based on our tests and evaluations, we found that 138 is a reasonable number.
Yeah, okay, I just want to add on to that because currently we have a lot of things that are, if you go into your TCS and you look at the percentage of links that are working at above 143, there are actually many.
There's always exceptions to the rule, Clemens, always. So it's just
No,
an overall recommendation.
I'm not saying this to. I'm just trying to ensure, because I've got a lot of teams doing installations where, so I want to make sure my teams align to the best knowledge as possible.
Absolutely, you're right. You're correct.
That's why I'm asking in terms of that to say. So, because I've built a lot, some links that I have that higher path loss, and they are giving the desired output in terms of speed test. So just wanted to get clarity on that. Thank you.
All right, thank you, Clemens. You're absolutely correct. There are links that perform high reliable links within the path loss of 141, 143. I've got a link that runs at 154. However, our overall recommendation, and like I say, this is the recommendation in South Africa, we want to try to get these path loss better than 138. Okay. So showing this picture on the right, you can all see under traffic test, which is the new menu. If you go to firmware release 2.0, you'll see a new menu called traffic test. It's no longer under the diagnostics page. If you upgrade your RN to release 2.0, there will be a new menu that says traffic test. If you run this test, you click something start, it will show the results as what I'm showing here. Now this link was actually tested in the Congo, and you can see this link was almost a 10-kilometer link, and I've managed to get these throughputs on that link. Okay. So what we pull is our downlink, the round trip latency If you want to tell the customer its latency, you take that number, divide it into 2. This is the round trip. It's from the BN towards the RN, RN to BN. Then we do the uplink. And then these are the 2 values that I was speaking about, the SINR. What it stands for is signal to interference noise ratio. And we measure this in the downlink as well as in the uplink. Now, we achieve our maximum modulation when this SINR value is 26. If this value is 5, then we're running at the lowest modulation, which means an aggregate throughput of about 130 meg. Okay. That's our lowest modulation capability. So this is where we measure the SINR. And then lastly, this is where the path loss is also available. Now, the path loss is made up of 2 carriers. So we measure both carriers, and we also take, we always take the worst of the path loss. So if you see a dashboard like this, if you go to dashboard and you look at these, you'll see 2 frequencies and you'll see 2 path loss values. Now, the one gentleman asked a question about receive level. What is the best receive level? We do measure the receive level, and you'll see this under the dashboard after the link is established for each one of the frequencies. However, this also includes interference. So this receive level is your base node transmitting toward the RN, including all other interference sources that's on carrier. Okay, just I want you guys to be aware of that. Yeah. Okay. Now, on the latest release firmware, there's a release note that I'll also make available to anyone that gets the firmware. We'll also put in the release notes. But something that I want to focus on, and you'll see why I stressed it before. This is the backwards compatibility chart. So if you have a BN running on release 2.01, an RN on 989 will still able to connect. However, the certificate is only valid now going forward from 997. Okay. So we've got a little note here to say the upgrade path. Any BN needs to be upgraded beyond 989, which means first upgrade to 997, and then we can upgrade to 2.0. Okay. So there's now an upgrade path. So what I recommend when you get a new RN, check it in the lab or at your home first. Log into it. Make sure the firmware is upgraded. It'll save you a lot of time on site because now you know that the RN is fully upgraded and the certificate is valid. And then going out to site makes your life simpler and less stressful. I hope that is good advice.
Is there any questions at this point? Because we have got all of 5 minutes left. Lee?
Yes, me. Sorry. So I just have a question. Will a 2.0 RN connect to 997 BN?
Yes.
Will it cause any issues? So no issues.
Yes, it will. It will connect. However, there will be some performance hindrances. It will still connect. So we've got here, if you look at this side, this is the RNs and this is the BNs. So if you've got an RN on release 2.0, it'll still be able to connect to a BN that's on 997. It's fully compatible.
Are we allowed to use 2.0 if it's available while the BNs are still on 997?
Yes.
Okay.
So the only thing that we're waiting for is the approval from MTN to say yes, they would allow us to upgrade the network. And as soon as that happens, I'll share the firmware files.
Okay, no problem. Yep.
Okay. Also, something that's new that there's just one hiccup in this thing, but we've also got an installer app. Now, this installer app, we've got 2 versions, one for Apple as well as one for Android, which would allow you to find the BN using your GPS and your phone and a map. So you can stand in front of an RN and you can see which BN it's going to connect to. So this installer app is soon be available for rollout. The only hiccup is we need to find the local manufacturer to create us the battery interface. So we've got a battery device that allows us to power an RN up to 75 minutes to make how can I say, installation checks faster. So it will power the RN, and you can quickly test multiple locations with this battery bank and using your smartphone to do a complete successful installation. So that's going forward. I have some photos if you guys are interested. I can quickly show.
When will the app be available for installers?
The app is already available. Our biggest problem is the battery. So
Yeah, but the battery is not needed for the smartphone to find the BN, surely.
Okay, so the smartphone will only find the BN, but will not be able to connect to the RN.
Okay, I see what you
RN
mean.
doesn't have a Wi-Fi interface. So the battery bank, let me just find it quickly. I'll show you some pictures.
We do have battery banks that are being offered to us from other technology providers, but maybe they'll work for this one.
So this is what the app would look like on your phone. Let's show you there quickly. So you can log in with your own credentials to TCS, email, and all of that stuff. And then you'll be able to see which BNs are in the area where you are currently based on your GPS location. And this is the battery system that we require. So this battery system provides PoE power to the RN, and then it also creates a Wi-Fi hotspot, which your phone can then connect to on Wi-Fi. So you have a dual connection. The phone will have a 3G connection on LTE in order to connect to TCS, and the Wi-Fi connection will connect onto this battery bank directly onto the RN. So now you've got two connections, one to the RN and one to TCS, which allows us the configuration to happen faster.
And you're not affected by load shedding because you can power this whole thing up.
Correct. I just want to see if there's more. So this is basically the effect. This is the low-level design. So RN, PoE cable towards the battery bank. We've got a Wi-Fi connection to your smartphone.
Okay.
So the firmware on the smartphone, the application is already available. We've run multiple tests on it. Our concern is the battery bank. So the problem, if we import these batteries, their MSRP price is 300 US. Now that makes it not viable for South Africa.
What's the kilowatt rating or the?
I can't remember what the kilowatt rating is, but I can show you one. I've got one with me. So next time I see you, I can show you one. But it's about a 65 watt PoE battery bank, and it provides power to a single RN for a maximum of 75 minutes from full charge.
Okay.
So I'm looking for a local manufacturer that can manufacture us a proper battery bank at a more reasonable price point. Okay, Lee, go ahead.
Okay, yeah, it's me again. So I think Andre's question was the app that will allow us to see where the BNs are, and that doesn't require the battery bank and the device that connects to the RN. So just that alone would make installations a little bit easier. The battery bank is kind of the phase 2 part of it. So I think it would be good to just get the app. We can trial the app for you if it's kind of almost ready. If it's in
so
beta.
we've been trialing it in I brought 2 samples in with the battery banks. So we've been trialing it with one of our test partners in Cape Town, and we're waiting his feedback. It's been good thus far, but this is what a picture of it looks like.
I think what Lee's is referring to is that if the techies just knew, the way the BNs are, and that BNs are actually up, would be far easier than what we're facing at the moment.
Absolutely. So that I'll push for that. I'll make a note of it, and let's see if we can get that faster deployed.
And then, so I've got a few other questions. So my next question is kind of firmware related. So when we search for BNs, right?
Yeah.
So at times it takes a while. It takes a very long time. Can we consider in the near future for us to stop the search once we have found the nearest BN? I mean, some of us have done installations in the same area many times over and over, and we know how to look for it. We find it, but it still searches and searches for another 5 minutes. Would we ever consider stopping the search and selecting the BN, and that's what we're going to connect to? If at the later stage it reboots and it finds something better, then that's good. But stop it and connect, you know what I mean?
So it's exactly what I mentioned before. I just want to get to that slide quickly and I'll show you. Where did I see it? Slide, that one.
With the different frequencies.
Yeah, so you can put a priority search list in, and this will
But
allow
then,
faster convergence.
yeah, but then we find there's many. So as you've mentioned, MTN only uses 2 frequencies. So,
Yep.
so even though you select those 2 frequencies, it is still going to search until it finds the strongest available signal and connect to that one, because everything is on that frequency. You know what I mean? So you're not specifically searching for the frequency of one BN.
Okay,
the
so
entire network is on the frequency.
okay, so that's the 2 points I want to talk to quick. So remember,
sorry, guys,
IDs.
we're already 3 minutes over, and I know that Wernfried's got another appointment to go to. So
let me finish this last point quickly, because it's very important and he needs to understand this. So remember I mentioned something like the planning IDs as well as the operator ID. So we're now running on operator ID 14. And I also mentioned that each and every base station now has a unique planning ID. Now, in the past, what happened is because all the base nodes were on the same planning ID, that's where the searching took very, very long. So the orange starts scanning, it finds planning ID 1.0, finds another BN with planning 1.0, and that's why it starts struggling to get the installation going. Going forward with all the planning IDs that have been updated, the RN search time should be faster because it now will find unique planning IDs and it will find those frequencies. So if you want to speed up the RN installation, you can take those 2 carriers if you know that BN is on that frequency. You can go to the priority search list that I've shown. Let's get there quick. Under the priority search list, you click configure and you just tick the 2 frequencies that you want to check, and immediately it will only search those 2 frequencies in the initial stage, speeding up RN installations. Now, if you interrupt the search stage and you click cancel, then it'll start the process again. So if that's a valid requirement that we want to say force connection to a specific BN, this is where you will put that BN's planning ID under primary BN and then click search.
Will that planning ID come with the planning file?
I've asked MTN to also include the planning ID, yes. So hopefully going forward, they will include it into the planning files, yes. So,
there's another question with regards to the saying, is there a possibility to connect to an RN using a cell phone or a tablet via an IP address?
With the battery bank, yes. So if you've got a battery bank that creates your Wi-Fi hotspot, yes. Very simple answer, yes, it is a possibility to use a cell phone to connect to an RN. However, we need that Wi-Fi hotspot to create that interface between the RN and your phone. So that's part of the installer app.
Awesome. Thank you. I know you pressed for time. We're 5 past already. I know there was one more. There was someone's hand up. Let me just.
Yes, it was me. It was me actually. I just needed to check because I couldn't hear for just a few seconds. Just wanted to check. I heard you saying that there's an app to locate the BNs that we can get.
Yes, that application is called the RN installation app. This is the battery bank I was referring to.
Oh, okay.
So that battery bank, it provides PoE power toward the RN, and then it also creates a Wi-Fi hotspot. And then you can use the installer app in order to configure your RN. And I do have a picture of that here. Let me just find it quick. Just to show you what it looks like. It's not this one. I've got so many. So the installer app will something look like this. You log onto your smartphone. This is a phone. You log onto your TCS credentials. So each one of you will have to get a radio installer credential on TCS, which MTN has agreed to provide once this app is launched. And then you'll be able to have access to the RN remotely from your phone, as well as TCS showing you the BNs.
So in other words, Cam, we are waiting for it to be released. So as soon as it's released, we'll be advised.
Yeah, so the application is already available. We just need MTN's approval to allow it. Yeah. Because the impact would be that each and every installer will have to get a TCS account, because you're going to use your app to log onto TCS in order to get where the BNs are. I've got a picture here that shows some of the BNs.
Awesome.
Yeah. So you'll.
I
have
know
in the
that you
app
pressed
show
for
your BNs.
time, Wernfried, so we can always set up a follow-up with you.
Yeah, so I'm still okay for now. They haven't called me in yet.
Okay.
Okay. There's a nice picture I want to show you of the installer app. So this is what it would look like. It will show searching. So as if you're logged in on the UI, it will show searching, exactly the step. It will show you your BNs, and it will start showing where these BNs are that it's connecting to. The spectrum part is for CDRS. Don't worry about that. But once it's connected, it will show you which one it's connected to. So this is your location on RN, and you've connected to that BN. And then you can also do speed tests. You can do a traffic speed test directly from your phone. It'll give the result like this. And you can then either run a screenshot from your phone. You just take a screenshot. And you can also do the telemetry configuration, i.e. the lats and longs, directly from your phone's GPS. So once you go there, you can immediately click edit configuration, and you can push your configuration straight into the RN. Makes life easier. And the nice last thing that I also want to say, you can do firmware upgrades from the app.
Yeah.
So you can download the firmware directly onto your smart device. And once you're connected to an RN using this device, you can then push firmware directly to the RN.
Yeah.
Exciting news. Very nice.
So this manual will also make it available. This is the app guide on how it works. This is still the beta one, but we'll make it available as soon as it's officially released for MTN.
Awesome.
Yeah. So those are the exciting new things that's happening with the Tarana, trying to make your lives easier.
Wonderful.
Another key thing is we're trying to change the way that MTN provides planning documentation to include more detail. And it's an internal, how can I say, they consider it as an internal project in order to get done, and it will take some time. So bear with MTN while they do this.
Douglas, you've got a question?
Yeah, this is more on an operational side, Wernfried. Obviously, MTN are your primary Tarana network operator, but is there a chance that the trained certified Techie technicians can actually get Tarana access to all of these applications? We don't have to go through MTN, because inadvertently we are installing for all sorts of carriers and network providers. So if Tarana are supplying technology to another network provider, if we had the certification, Tarana certification, and access to all of these tools directly with Tarana, we could actually provide the services across the board.
Absolutely, you're absolutely correct, Douglas. So there's nothing from Tarana that's stopping us from doing this training. So we do have what we call an initial certified training for installations and configuration for both PN and RN. That is a classroom-based course that we can run. The only thing is, if I train people for MTN, then I obviously have to do it for MTN's network. But if it's like a third party and we have equipment to do the training, absolutely, we can schedule these trainings and we do it. And then we're also currently working on an advanced training course where we want to give each and every person that's attending that course a unique number, allowing them direct access with Tarana for more documentation, for firmware upgrades, for early access, for testing, all of those good things. So you're absolutely correct, we do that.
That's brilliant.
Yeah.
Yeah. So I'm wearing a My Techie hat here, whereas we currently installing for MTN, as you know, but by My Techie guys getting the direct Tarana certification and tools and all the rest of it, it actually opens up opportunity for Tarana in the country as well. Because then you
absolutely.
So yeah. Just my 2 cents worth. Sorry.
And then there's another question here for you, Wernfried, saying, so at what wattage does the RN power at?
Okay, so the RN is a PoE plus device. It consumes 33 watts of power. It's a 56 volt device. So that's basically the spec. So it's a PoE powered. The NTN RN is a passive PoE power device, which means you have to use the PoE power adapter currently from Tarana to provide the passive PoE power. But more or less, if it's in the industry, they also call it a phantom mode PoE. It needs to be 56 watts, and if you need the pinouts, I can provide that. But it basically takes 33 watts. It's a PoE plus device.
Awesome.
Yeah, it's quite heavy, because one of the applications we're looking at for a client is putting them into areas that don't have power and using solar to charge a battery, and the battery to keep the RN up. So it's a fairly meaty thing, but we're looking at that. Just quickly, another question. When you've got your RN and it's all lined up with its primary link, and if the primary BN for some reason goes off the air, gets vandalized, switched off, it now looks for another alternative channel. And if that one is too poor, the client's experience might not be that great.
Yeah, I agree. So that feature is called primary BN. And the primary BN is configured on NTN's network to automatically switch back once the primary BN is available. But how this works is, and the reason why it's implemented, it's better to have some service than no service.
Okay,
so
understood.
That's one of the reasons. So if it's on a secondary BN, there's always an alarm on TCS that shows this RN is not connected to its primary BN. And that could be because of vandalism or power outages like load shedding. MTN has had a massive drive to improve their reliability on sites, meaning they've installed backup power where BNs are installed.
But it will switch back once the primary is back on the air, right?
Yeah, that's correct. So as soon as the primary BN is stable, TCS, which is our management platform, will instruct all the RNs to go back to their primary BN. Yes. It's done automatically. I do have to also tell you that there is a drop in connection. So the RN will disconnect from that BN and re-establish a connection towards the primary BN.
Awesome.
Which may or may not be noticed by the client.
If it's at night, they will never notice. But for example, if it's during a Teams meeting, they will notice.
Yes. Okay.
All right,
thanks.
awesome.
Awesome.
We can always schedule more of these sessions. We can deep dive into tech. We just schedule them, and we can deep dive into the technology a bit more.
That would be wonderful if we can do that.
Regular. Yeah.
Yeah. Guy, to the techies, what's your feeling? Thumbs up?